It's like salut. You can say salut.
Salute. Salute.
No, salut. French.
Salute.
Salut.
Salute. Salute.
We're ready to start. So today we're going to take a look at classes, how they are constructed, how they are and how they the body of the class works, how you can actually set up setter and getters, and then since classes are objects, what's the class of a class and how can I control them, right? So these are the topics I want to do today. I expect by the end of the lecture we have a deep understanding of how the class gets generated, how Python interpreter treats the body of a class and so on. And we'll start exactly with that. So the class body is nothing particular. It's not like in C or in C++ that there is a compiler that has some grammar inside. The class body is just a scope. Variables get defined in it, and each variable that gets defined in it ends up in the namespace. And each statement first gets evaluated for whatever it is. The result is appended to the class dict, which is the namespace of the class, and that's it. And you can put any valid Python within it as conditional loops, imports, next is class function, whatever you can write outside of the class body, you can write inside of the class body. It's not much of a constraint, right? And this we're going to exploit later on and see what we can do with that. But first we want to do a bit of theory on something else. A descriptor, what's a descriptor? The descriptor is what you actually use behind the scenes when you call a function or property. Second, let's join. Anyway, let's start from there. So, so a descriptor is something that get used behind the scene when you call a function or when you have that property, for example. But you can control it yourself and actually define it. And it's basically the way that Python implement getters and setters. So we'll look at the implementation first, and then we'll dig a bit into how that actually works. So if you want to define a descriptor, what you have to do is just create an object. You don't have a subclass. You have to just conform to a certain protocol, which means you have to implement either a getter or setter or both, or delete, which I didn't include here for simplicity. But this is basically how you implement it. So once you have implemented it, to implement it, you have the two methods. If you're in the getter, what you get is self, which is the descriptor itself, and you get the instance of the class that you have placed the descriptor inside. You usually place this inside the class, right? And then you get the class itself. So if I define an object from a class A, this would be A, this would be the object, and this is self, the descriptor instance. In the set value, you get the instance and you get the value. You don't get the class to work with, but you get the instance and self. So, and then you can do with it whatever you want. You can create a shadow value, you can do basic initialization, you can do caching, you can do what you prefer with it.
In the get function, why the instance and class are not involved in the body of that function? So what is the purposes for?
So, I mean, later we'll see the lookup of the methods and how that works in detail. But you find out that basically when you set the value at the instance level, because this is called the instance level, you want to actually work with the instance and the value itself, not really with the class. Well, if you do a get, the get always looks up first in the class, right? For the setter, you don't have that kind of necessity. So you can always access the class anyway through instance dot underscore class, right? But it's not so important. And the way you then use this is by putting it into your class definition as a class variable. This is important. We'll see why. It works only if you put it as class variable. Questions? All right. So the descriptor is defined into the class scope, but it actually influences also the instance variables. That's important, right? You define the class scope, you use it in the instance. a variable. If you try to, we'll see later why. If you try to assign a variable at the class level, where there is a descriptor, you're actually overwriting the descriptor. You put in a new value for that thing in the class variable, for that name in the class variable. If you use it at the instance level, then it's actually using your setter, right? And that's important. So what we have is basically that you do something like this. So you define the descriptor as a class variable. You then create an instance, and when you call for.bar equal to a, this calls the set of the descriptor, and when you call for.bar, this calls the get of the descriptor, right? But you're doing this at the instance level, not at the class level. I'm not calling for.bar. If I were to call for big capital case bar equal to a, that would substitute this class level, sorry, this class level variable with a instead of the descriptor, right? Clear?
But why would we have to do that? Because you have a class variable, actually you can directly call the class variable and set the value for that. And why it is better to do it by descriptor?
So if you have a class variable, of course you can set it directly if you just use an instance variable, but you cannot do anything that you might want to do. For example, type checking. You might want to do list initialization of the variable. You might want to do a lot of things in the getter that you want to hide from the client, from the user, right? This is where
something like maybe there's a set function, you have an input and you do a lot of stuff, and then you put it in the class variable. But if you do it in a descriptor, then the user only need to say, okay, full bar equals to something.
Exactly. It doesn't need to know what else you might want to check or do or prepare when you do that. Maybe you have to initialize. Maybe you have to initialize a container to put that variable inside, and you want to lazily do that when the first variable hits the class or the instance, I mean, and then you can do that in the set. You can check, initialize, and then take care of the value that arrives.
And also for the function get, right?
Sorry?
Also for the function get,
Also
maybe
for the function get.
that you want to do something else. You want
Absolutely. Another case is if you want to monitor these settings and gettings. If you have an event-based architecture where you say whenever my value, for example, if you have a UI and you want to refresh the UI whenever the value on the, let's say, module changes, then basically you put it in the setter, you trigger the event on the UI when that set is called, right? This is a typical way to use the setter.
But in fact, actually, you cannot really hide it, right? If I know the name, I can still directly set it.
Yes, there's some limited private functionality. Is not really private, it's name mangling. So if you call a variable __ bar, but you don't put more than one underscore at the end, right? This would get then renamed into __ for bar __. So nobody actually will probably manage to overwrite it, right?
But still,
it's your variable.
But still, you still can do that if you want.
You need to know the mangling, and you need to override the mangled variable. Because for you, the local scope, you would always use the original one, while if somebody redefines your variable, it would use a new private one for himself. Yeah. So that's how basically Python implements a limited private variable. Okay, but you can still do it if you know how Python works. You can always understand.
I assume that you will not do something bad.
No, I mean this is criminal intention, right? You can do something like that. All right. So
Daniela, question.
Yes.
This on the previous slide, the bar is it the foo bar, the foo bar is it a class variable if you access it, or is it an instance variable?
It is sorry, it is both, right? You define it as a class variable. As a class variable, is definition is descriptor, right?
Yes.
But when you call it on an instance, it behaves as an instance variable. And when you call it on the instance, we'll see why it does that. When you call it on the instance, it uses the getter and the setter of the descriptor itself. So on the next slide, you saw that graph. We'll see how the lookup works in detail. So then you can figure out why it actually behaves like an instance variable and it makes sense,
Okay.
right? So with that, for the second time, we'll go to the next slide. So what we have, when you call for.var, what happens behind the scenes is that, yeah, it's been tried, right? What happens behind the scenes is that you have the interpreter calls for.get attribute bar as a string, and that's basically always whenever you call any even init is going to land here, and so we'll see that you can override this, but you have to be very careful not to get into a loop. You cannot use the dot syntax in here because you're going to infinite loop. But let's forget about this for a while. So what happens inside get attribute? The first step is that get attribute is going to check if bar is as a string is in for the class dot dict, right? If it's inside the dictionary, then it will check one thing: if this object, which is for dot dict bar, has a setter and a getter, right? If it has both, it proceeds and it actually call this getter, and then it returns whatever the getter returns. This is at the class level. I marked this in blue at the class level. This is at the instance level is in yellow. So this is the thing that we actually abuse when we define a descriptor. We follow this trajectory, right? So you are at an instance. The instance for gets called bar. Then the interpreter goes at the class level, checks the gets attribute at the class level, and then it follows on. And you get for.dict bar gets, and that's what you get at the end. But then if one of these two fails, the next step is actually going at the dictionary of the instance, not of the class. Right? If you are now at the instance level, then you check if bar is inside the dictionary, and then you have to check two cases, right? If it is, then it just returns whatever is there. But if it's not, well, then it checks if bar is in for dict again, and if it has a getter, right? So now we are in the case where we don't have a setter and a getter. We know that we are not indexes, but I want to check if it has a getter. If it has a getter, I'm going to call it anyway. But this only happens if I haven't already defined something at the instance level. So, for example, this is the case of a method. If I have a method and you call it bar, the method has a getter, as a get. This is basically the function that you assign to that method. And this gets called unless you redefine that method inside the instance. If you redefine that method inside the instance, you do for.bar at the instance level equals something else, a value, then it will ignore the method and will just return whatever you understand in the instance. But if you have a property is as a setter and a getter, the decorator property, if you ever use it in Python, will follow this rule. So you can actually try to redefine at the instance level. You cannot override. It won't work because the lookup is going through this all the time. So then there are the two other cases. I mean, if bar is not in dict, then it will call this fallback, which is get at bar, which we will see. It gives you the possibility to dynamically define parameters, variables inside your instance or inside your class, and we'll use it as well. And if it has an instance but doesn't have a getter, then we'll just return whatever is in the dictionary. This might be actually a plain old variable inside the class, right? And then it just returns it. It doesn't have a getter, so we don't have to call it. Any questions about this before we move on? This is a bit of the internals.
What is the role of dict?
Sorry?
DICT from the dict function. So what is actually?
What is dict?
Yeah.
Dict is the namespace of the class, or in this case of the instance.
Okay.
So in full capital case dict, there is basically all the methods, all the class variables, everything that you define in the namespace.
If it's a function defined by default in Python, or you need to write it by yourself?
We'll see exactly how it's defined. It's defined by default, but you can actually control it. And this is one of the use cases for meta classes. We'll see later. right? But it is actually an ordered dictionary that gets created from what you write inside the class file.
Yeah, so, okay.
Okay.
Is there a difference between single underscore dict underscore and double underscore dict?
Yeah, the difference is that I made a typo. That's the difference.
Okay.
Sorry about that. I correct that. Yeah, it's a typo.
Also in orange.
Yeah, the orange, sorry, the orange and the yellow, I try to differentiate. This is happening at the instance level. This is happening at the class level. So just to make sure you understand this. Because again, the important thing to remember is that these are called data descriptor, the one that you have set for. Data descriptor evaluated first. Then the instance dict is checked. And only then, if the instance dict doesn't have a variable, you have the other descriptor evaluated. And only then you have the variables. And if you don't have any of this, then it falls back to the adapter. Which is basically, if you have implemented it, you can define whatever you want in here and return whatever you want. Right? So this is the 4 stages. So far, so good? All right, and let's move on. So descriptors. Descriptors, again, now you understand why I defined as class variable because of the attribute lookup. If you define it as instance variable, they would just return whatever they are, right? And you would not be able to use set because actually that's not true what I said before. The getter would be used, but the setter will never be used because when you assign them, you just override the descriptor as an object and put whatever value you put. So you wouldn't use the set argument. You would use only, it's a set method, you would only use the get method. But you can define it at class level, because if you define it at class level, then basically from the instance through the lookup, you get to the setter before you actually go into the instance dictionary. And this is, if you think about it, how also methods are defined. Methods are defined at the class scope, at the class namespace, but then use them on the instance, right? You define a method in the class namespace, it lands in the class dict, and then when you call it on the instance pass itself, and it just acts on itself. But it is a member of the class namespace, it's not a member of the instance namespace. And that's exactly the same for descriptors, where you have inside the descriptor, you have this instance variable, and this instance variable is what self is in a method. Make sense? Okay, move on. So this is a second. So data descriptor implemented set are lookup first, cannot be overwritten at instance level, right? So because the instance lookup is happening after the class lookup for set descriptor, and get on the descriptor can be overwritten at instance level. So if you have a method, you can actually reassign that name to something else, to a new method, or to at the instance level, not at the class level. You can just take your instance dot whatever the name of the method was equal to something else. So property is a descriptor and it's a data descriptor. If you ever use property, it basically turns your variable into basically your function, sorry, not your variable, your function into a setter getter variable, right? And you can call it then without the parentheses. Class method, static method are get only descriptor as all the other methods. We'll see actually in the demo how you can actually see this, because you just can print if it has get or not, and they all have get. Any question about descriptors?
We need an example.
Sorry?
We need an example.
Yeah, we'll see the example later. But first, let's finish with the theory, metaclasses. So objects are classes are objects, sorry. So the question is, what is the class of a class? And usually it's type. Type is the class of a class. If you do whatever class you have, dot underscore underscore class, we saw that it's type. But you can redefine it. You can define your own classes. These are metaclasses. And so class is an object. Class is a subclass of object, right? Sorry, an object. An instance is a subclass of object. This is wrong. I don't know why I wrote that. An instance is a subclass of object, and a class is an object of type type. A metaclass is a subclass of, sorry, this is actually correct. A class is an object of object type. Okay. A class is a subclass of object. Object is the main class in Python, right? So what is a metaclass? A metaclass is a subclass of type. You're actually subclassing type so that you can inherit the ability to create new classes, but you can intercept its behavior, right? So most of what metaclasses do are better implemented with other methods, like standard inheritance, like decorators, but for some tasks, you can't do it. Basically, these all involve extending the language, creating things that were not possible in Python before you started working on this. And we'll see a few examples of why metaclasses are used. Usually you don't have to use them, but it makes sense to understand when you're reading, for example, the code of the library, how do they actually interact with your code, right? And why? Because documentation is not always the strong suit of Python library, so you usually want to look at source code and understand it when you have something to debug. So, and then there is some black magic in classes, which is the method prepare. And this is really the only reason that you really need to use metaclasses. If you want to work with this guy, then there is no other way. Prepare is actually the methods that creates the namespace of a class. So usually this is an order dict, and you just get it from the interpreter. But if you want to actually change the behavior, like you want to do something like implement, we'll see that later. You want to implement, for example, overloading in functions. So you can create the same name of a function, but with different number of arguments, and you want to support it in Python. You can do it by changing this dictionary and supporting multiple values for a single key. And that is how you use this. We'll see an example of this. So, but this is really the only place where you need metaclasses. Otherwise, you can always do it differently. Sometimes, though, metaclasses are better than decorators. We'll see why exactly and how. So, use cases. Registration. Let's say you have a database. This is a typical example, a database, and you want to keep track of which classes have access to this database because they are subclassing some table class, right? So you have different tables, each class corresponds to a table. They are subclassing all these tables, superclass, and every time you're subclassing, you want the manager of the connections to know that this class is subclassing, so that you can manage events, you can send data, you can retrieve data, you can do all kind of cleanup that you need to do in this class. Well, you can do it with metaclasses. You just basically intercept the initialization of the class. You register that class in your manager, and you just go on with your life, right? That's one of the cases. You could use metaclasses. Modification. Well, of course, the same that we did in decorator. You can do it in metaclasses. Decorator get the class at the end of the initialization, and then you can change it. But metaclass, you can actually intercept the creation of the class and modify it while it's created. You can do before the object is created, you can do after date, you can do whatever you want. So you can use it the same way as we use decorators to modify the behavior of class. You can do special syntax, like you can implement something like a key lookup at the class level. Right? We did it at the object level for containers with get item. But if you have a meta class, you can implement the get item in the meta class and therefore have the key lookup at the class level and not at the instance level. You go just one step up, right? So you can do this. You can say, okay, I have like a class generator, which is full, and then I give it a descriptor, which is bar, and then it generates for me a class that corresponds to that loop. This actually, since recently, I don't think it existed before last year or something like that. So you can actually implement the class get item. They fully down at the class level, so you have a special method to do this. But yeah, besides that, you still do it at metaclass level. This is usually something that you want to do when you have generics, right? If you want to implement something like a list of some special type, then you can do it like this. You pass the type as an argument, and then create the container for that type as a class, as a specific class. You might want to do some initialization, something special to treat that type in particular, or you want to maybe do type check when you append an object or something like that. So what else? Parametric class. Now this is tricky. So if you want to, for example, pass the role that you want to check for access to this particular class functionality, you can actually initialize the class, not the instance, the class as a probably the microphone is off. Yeah. This is the chat.
We didn't say anything, I think.
Okay. Yeah, I keep receiving this ping, so I don't know what it is. Anyway. Yeah. So if you want to exactly, if you want to, for example, pass the role that should be used for getting field authorization in the functionality of this class, you can pass it as you would pass the superclass, right? At the same level. When you define the class, instead of passing the superclass, you can pass the superclass plus some other keyword arguments. And within the meta class, you can use these keyword arguments to do whatever kind of initialization you want. It's kind of a decorator. The difference here is that this is actually inherited by the subclasses, while the decorator is only active on that particular class where you put the decorator. So if you plan to let other people use this class and subclasses, you shouldn't use the decorator, you should use the meta class to do this. So other things, well, you could implement in the noun a C-style noun, and we'll see one example, something like this, which doesn't make absolutely any sense in Python, right? I mean, it's just listing some names with no values. Well, you can do this with metaclass. You can implement this, assign automatic values to those, given the order, and you do that with the prepare method. So this is how you extend the language. And then, if you call colors blue, it will tell you it's 2 or 1, depending how you count. Right? Yeah, it's we'll see how it's implemented. You see the example with the code exactly how it's done. And then you could also implement overloading, the thing that I talked about, or even more interesting, you could dynamically generate class. So, for example, this is a case I actually had in one of the projects I had. So, let's say you have a client-server system, and you have one part is developed with Java or C, and the other part is developed with Python. And you have to develop like common functionality because you want to be able to treat the data in the same way on the server, on the client, without always communicating back and forth, right? So for example, you can cache the data from the server to the client, and you want to operate in the same way on the client that you would on the server. So because you want to support web interface as well as client, because you want to support. So anyway, anyhow you want to do it, you have to implement the same code on the client and on the server, duplicate effort. What you can do is you can actually support a subset of what you develop in C, pass the class to the other side, and then generate the same classes in Python using dynamic class generation, using metaclasses. You basically do this dynamically, and we'll see a little example of this. So a very stupid example is if you have a data set, for example, that is in JSON, and you want to parse it and you want to expose this data set as Python objects. So each different object is a new class that you have to define in JSON, not in Python, and you just generate those automatically, right? And this is another way that metaclass could be used. But in general, as you see, there are very special things that you can do in metaclass. It's not really something that you want to use every day. But you find those in the libraries here and there. Any question about this? Right. So Metaclasses and decorators. Let's see why they are different and how. As I said, first of all, you want to participate in your inheritance and you want to implement something that goes across objects and modules, use metaclasses. If this is not a problem, use decorators. First, big difference. Second big difference is, yeah, I mean, this basically ties in on the above. This is default behavior. Once you define it, it's class and so on. It's nothing special. This needs to be explicitly called. If you have a decorator, you need to put it every time in the class, right? And the decorator is not access to class syntax. The decorator is changing just the class object after it has been created. But with metaclasses, you can do some weird stuff, black magic, like we saw with the enum and the overload. And that's why the reason is that the decorators act after the class creation, but the metaclasses actually are early in the life cycle. Actually, you can inject yourself at every step of the life cycle of the class creation. And by the way, you can also do, but I've never seen a use case for that. You can also create a metaclass. Metaclasses are objects, so you can actually create a metaclass to generate metaclasses to generate classes, and so on. Can go on forever. So that's it. Now we go to actually the interesting part, which is M's. So let's start with small. Can you read?
Yes.
Okay. So let's start with what is the class body? Back to the first slide. So in the class body, I can pretty much do whatever I want, right? So I can import the module. I can check for, I don't know, if today is an even day or an odd day, and then define in it only in case it's an even day. Or I can actually write a loop and append values to something that I have defined in this code. Because again, the body is nothing special, it's just a piece of Python code. And what I define here lands in my namespace. That's all it is to the class body. Right? So if we run it, sorry about this, I need to move this guy. Okay. If we run it, is well, no init today because 5 is not even. And then we have the list that I've looped through is then 0, 1, 2, 3, 4, 5, right? So I'm printing basically here, checking if even or odd day, and then calling the even or not. It's not calling initialized because it's not being initialized. And the A is being, printed here is just a list from 0 to 6. So for example, if you have to initialize some variable inside your class body and you need some advanced initialization routine, you just write it in there. You don't need to check, okay, what's the syntax? There's no syntax, it's just a piece of code. Right? The only thing is that you can assign. Yes.
Quick question. So if you create A, for example, here, which means you create an attribute to this class.
Yes.
Okay.
So exactly, it's a class variable inside my class, and then I can manipulate it within the class body directly without actually calling the new function after initialization. I don't have to care about this. This is a piece of code that gets evaluated, and then the namespace gets defined. Of course, you need to know, be careful. I mean, at this point, there's no instance. There isn't even a class, so you cannot actually access other methods of the class. But you can access this variable because just defined. It's within your scope, right?
Wait, so we directly write a piece of code in the class without defining a separate function.
Exactly. The class body in Python is nothing special. There is no compiler. There is nothing. It's just, plus the class is just again what we say. It's just some syntactic sugar, right? You have a piece of code that gets evaluated. Every variable that is assigned at that level lands in the namespace. Then the class is composed, and basically namespace is assigned to the class, and that's it. And you have a new object with the underscore and underscore date, and that's your class. But this is just plain old Python, which gets evaluated at run, at a class creation. Make sense? Yes.
Yeah. So I noticed that there is since the import some packages, right?
Yes.
So my question is it okay to import any like necessary package whenever you use that, or just to import everything in front of the beginning at the beginning of the script.
Right, let's say that you are, for example, you're using a driver. The driver depends on what hardware is coming, right? And you want to import that driver because it has conflicts with other drivers only if you attach that hardware.
Okay.
You can control this like this, right? You can put it within an if, define the class only if the hardware is present, do some pre-check, and then load the appropriate drivers. This is something you can do in Python quite easily because it's all dynamic, right?
Another question, the import only valid within this class, or once you import it, it is valid everywhere in the code?
The import is valid.
Okay.
In this example, we never have an instance of the class, right? So wouldn't the init then never be called?
The init is defined within the namespace because I define it as def init is equivalent to init equal function with a lambda.
Yeah, sure.
So since I define it in this piece of code, it lands in the namespace. Once it's in the namespace and then I create an instance, the instance creation will check if the init is present and then will forward.
Yeah, but this is what I'm saying, but you never create an instance here, right? In this code.
It's not yet called. If I create my class parenthesis, then would be called. Yeah, you're right. Yes, I wouldn't.
So the initialize would never be printed.
Yeah,
even if it's
absolutely.
a-
You're absolutely right. So let's
Okay, good.
let's be more explicit. So if I run it now, then again, it's
Yeah.
okay. You're absolutely right.
Second question, so
Yes.
how A is transferred to the, because if you say 5 and
So you want to know what this is?
no, I mean,
Mhm.
I print my class dot 8 and when did I assign 5 to?
Here. I went from 0 to 5 and I appended all this.
Okay, and how this number is, how this A is transferred to the code beforehand. So because you need to divide it by 2 and see whether it's an even number, but how this variable is transferred to the code beforehand. I didn't
No,
see.
wait a second. I have an if here, right? I have an if here that is only checking if this is even or odd, and then either printing this and defining it or printing this.
But A is defined afterwards.
If this is
Okay.
outside the scope of the if else. So this gets always executed, right? This
Okay,
is
something like-
implemented with the basic.
I understand it this way. So the first one, there's nothing in A, so it just skip the code between the if structure and later they have
So the if is false, right? So this is skipped, so there's no init, but else is executed, and then it goes back to the main scope of the class file. Make sense? If I unindent, I get back to the main scope, right? And then I just keep going.
But I mean, if you want from the top to the end,
Mhm.
the first thing you need to run is run the if
Import.
code,
Yes,
import, and then run the if code. But
yes,
at this moment, you didn't define any A yet.
no,
You don't need to define, like you seem to define a something, assign some type to this.
But before the if structure, the
Yes.
A is not assigned to anything.
right, oh, you're right, I'm not using it in the
But
structure,
why?
I'm using it
But
only-
yeah, it's only used afterward. Then how do they know that afterward you will have a 5 for that, for example?
I don't use a here. What do you mean afterwards? Afterwards, I mean, in the init, there is no a. I'm just defining it here, so it lands on my
Okay.
dict.
So the a is
So
also
it's just
the if.
assigned as a
What's
class
the
variable.
date?
Doesn't make
Okay,
sense.
It doesn't
Yeah,
matter.
I know,
Yeah.
I know. It's a coincidence because today is November the 5th. So actually at the first code, you're not using the value of A, you're just using the day divided by 2.
Yeah, there's no a.
But today is
Date
November-
time,
It's
date
Yeah.
time, date- Oh,
And
now I
today
get
is November the 5th.
Now I get your question.
Yeah.
Yeah, I'm not reading from it. It's just to show a silly example of how I can, make the
great
class
coincidence.
definition dependent on some variable that is just there.
A great
Which
point.
is very useful.
Yeah, it's absolutely not useful. I mean, but you could land, for example, this could be a checker driver, right? If I have this driver active, if this PCI is connected, then do something, right?
I have a question. So if we have a function after A,
Yes.
after A, then how can we use the A in the function? Like use it as the self dot A or just A?
So def bar self, right?
Yes.
And then print A.
Okay, just the A.
Self.a.
A, just A or self.
Self wouldn't work.
So
So actually would actually also work, but then you're using the A coming from the dict after the instance is being initialized through the lookup. If I do it like this, I'm using it because it's in the local scope. So I can still use it. I can pass it through the local scope. So that's two different A's. You can do it like this.
So it doesn't cause any error if I use self dot A here.
It shouldn't. I mean, let's try. I don't want to die. No, it doesn't. It prints.
And this works, but I need to self dot A.
But we never call bar.
Self dot.
Yes.
Then, oh yeah, it doesn't generate any error because again, good point. Let's do that, huh? So it prints. Now let's try without the self. How about that? It should work because it should be in the local scope, so it should actually inherit it from the local scope. And no, it doesn't. Name A is not defined, so you actually, yeah, when you enter the function, the local scope changes, so you're actually forgetting what you had in the class scope. You have to pass it as
Okay.
So if you wanted to access the class attribute, then you need to write self.class.a.
Or you can just write my class.a. Yes.
Yeah.
But what I was trying to do, I was trying to actually use the nested scope, but in this case, it doesn't work. All right. So, any more questions about this before we move on? All right. Let's go into the get_at. So get_at is a method that you can use, if you remember from the lookup structure. This is basically the fallback. If something doesn't exist in the init, in the dict at any level, then it will check your get_at. And what we are doing here is we're basically overriding the dictionary so that we can use our own whatever dictionary logic inside, and it's go through the get_at. This code is pretty easy. I initialize this with a dictionary that I get passed to, and when I do a get_at, I return the value inside the dictionary. So in this case, I can use .for instead of bracket for bracket. Right? Some magic trick. And yeah, I can do that, so I can dynamically create methods like that. Property like that. Yeah. And yeah, that's it. That's what get_at is about. Now remember the difference. Get_at is a fallback. Get_attribute is a catch-all. It always goes through that first, right? So in get_at you can do stuff like calling other instances from self. Like here, I can call set.dict because set.dict exists. So it will not go back to get_at again, but it will go back to get_attribute. If I implement the get_attribute here and I try to call self._dict, I will go in your endless loop. Right? Questions?
A little basic question regarding Python. So the running logic for Python is that you execute specific .py files and then you run from the beginning to the end of this py file, and during that time maybe it will call another stuff and then they execute that. So from the beginning to the end, there's nothing like main function or something like that.
No, the main function is whatever you define that gets called at the global level first. Right? I mean, you can create a main function and call it. You can call it also John and call it as John, and it's
Because
there's no special meaning to me. It's just a convention. So let's move on. And let's look back in at the singleton. I know you can't stand it anymore, but I wanted to show you a different way of creating a singleton using the get attribute. And this is actually a cleaner implementation. What it does is actually creates a wrapper around the instance that you want to use, and then it does the following. It blocks your new, so you cannot create an instance of that class directly. It creates a method getInstance that will retrieve the instance that you want to use, and then it will use getAttribute to pass every call from the wrapper to the inside class and back. In this way, you basically have complete control of that particular instance, and that's a cleaner implementation. So if you implement it like this as a decorator, as you see, the decorator takes the class itself, right? It creates a wrapper class, and then when you call new on the initial class, it will give you an error. When you call getInstance, it will check if the instance is there, if it's not created, by using the orange class here, and it will return the instance itself. And if you get attribute, the only thing it does is just get the attribute from the instance and send it back. And in this way, you can just use it as well. So basically, if you try to actually initialize foo from here, it will give an error and we'll never get to this print here, right? So let's try it. There we go. So the increment is 1, but then we got an error. The error is use getInstance, right? So that's our new singleton using a get attribute. Questions on here? So I can do this, by the way, because I am implementing the get attribute and not the get attribute. So if I was implementing the get attribute, everything will actually, something will not work. For example, I could directly access the underscore instance. Good. All right, let's move on. So the descriptors. Descriptors, as we said before, we implemented getter and setter. And we, if we have a class, we just define one as a bar as a descriptor, and we can now assign values to bar and read values from bar. What I wanted to show you with this small demo is that the same holds true for def bar or class method at bar 3. They all have the getters, but they don't have the setters. So in the demonstration, I just do foo, and then I print bar, I assign bar again, and I print bar again. You see that it works, even if I just create the bar. Right? Questions on the code before we run it?
Not about this code, just continue with my previous question. So you say that class in Python is a syntactic structure. So something like, actually we can, let's say before the first line of this code, actually I can write, for example, a equals to 1, b equals to 2, and then I define a class, and then I print something
here, or you can do it out here. You can do global variables.
Yeah, I don't need to write every class. I do not necessarily write all the class things at the top. So I can create a class on the fly.
Absolutely. You can create it nested inside another class, like we did for the decorator, right? We created a class inside another class and then returned the class. Right? I mean, did you see that? Right? So in the singleton, we are defining a class within a function, and then we're returning the class.
Okay.
Right? So class is an object, so I can create it, I can return it, I can modify it, same as any other object. And class, wrapper class is just again syntactic sugar for wrapper class equal to new definition of class, which is type and so on.
Is it speciality of Python or for all object-oriented and the programming like C++?
No, so the thing about Python is that not many other languages have it, is that this is completely dynamic. The point is that classes are just first order citizen objects. They don't have any specialty about it. So I could actually rewrite all the syntax by writing wrapper object equal to type as a string wrapper class, comma, empty tuple because it doesn't have a superclass, and comma, a dictionary with these three names with the function definition.
Interesting.
And that's basically what wrapper class column is. It's nothing else, a syntactic sugar for calling type with these three arguments, right? So you're not using any extra language specific property. You're just you just have a nice way to write something that at the basic is just function call. So you might argue Python is not even an object-oriented language, it's just a functional language or scripting language where I have defined classes within the language itself, just giving some syntactic sugar. It's like that, it's really dynamic. So that's why it's so flexible.
We have some
dealing with it.
already feeling that's too flexible. So
You can do some unreadable code in Python, right?
yeah. I mean, I cannot be. I can be not so flexible so that it's more readable. I mean,
Yeah, absolutely. I mean, you have to keep in mind what you're writing. What I mean, just because the meta classes exist, you don't have to use them, right? But it's important to understand how they work when you're reading it. So again, back to the descriptors. Let's run this. Let's try to understand what's going on, right? So remember, bar was the descriptor. Bar 2 was a method. Bar 3 was a class method. So if I'm checking for getters, right? I get, if I call, let's see, if I call foo bar on the class, right? And I check if it has get, it doesn't. But if I call it, if I check the dict object bar, then it does. Make sense? Somebody explains me why. Explain me why. This goes back to the class lookup. If I call foo bar, remember foo is an object. What class lookup is going to happen? What's the class of the object foo? Is it foo? Capital case foo? No. What is it?
Object.
Type. Type. What's the class of a class? It's type. So the class lookup will go into type, check the dict of type, check if there is an object bar, and see if it has a getter. But there is no object bar in type. There is an instance object in bar, in foo class, an instance object that is called bar. Because this is a class, it's not an instance. But if I check the dict of bar, basically what I would check if this was the instance and not the class, then I find a get. Remember, so there's a bit of understanding to be had here. If you want to deal with an instance, getters and setters, you have to look at the class dict. If you want to deal with the class level getter and setter, you have to look at the meta class. It's always one step up. So you'll never be able to access the getter from this kind of series. Because it doesn't make sense, because you need to define it one level above to do that. So you need to metaclass it, you need to define the getter at the metaclass level, and then you can access the metaclass level. But you usually don't do this. You usually want it at the distance level, and then it's enough to check if it is there, right? This is exactly what the class lookup is. So if you check here the getters, they all have getters. Bar is a getter, bar 2 as a getter, bar 3 as a getter. They are methods, so they can be the value can be extracted from me to just call the method. So, and that's basically what it is. But if you're looking for setters, Well, the descriptor has one, but the other two don't, right? So if you go and run it, you'll see that exactly. So you have, when the direct call doesn't work, we know that. Then we have all three have a getter, and the setter is only true for the descriptor, not for the listings, right? So they can be overridden. Now, I'm then using it, and I'm checking, okay, I'm creating the class, then I'm printing the value of bar, which is known because I didn't initialize it in the descriptor. Then I'm assigning one and I'm printing it again. And what happens is that what I would expect, right, is it's calling the getter, printing none, then it's calling the setter, calling the getter, and printing one. Nothing new, right? Any questions about this? Wanted to get at least in one example of metaclasses before we finish. So far, so good. Metaclasses. All right. So metaclasses are a strange thing. What you have this special method in metaclasses, which is new, and it's the same old new, right? But it has 4 arguments this time. The first one is basically the self of the metaclass. It's the metaclass itself. The second one is the name of the future class that you're going to define. Right? When you want to create a class, you call the new in the metaclass, and this is the name of what you're about to define. Then you have bases and attributes. Bases are the superclasses of the class you're about to define, and the attributes are basically everything that is in the scope of the class file, right? And then you create the metaclass. Basically, here I'm just printing out the stuff so that we get a look at what's inside, and then I'm just calling super so that it's falling back to type, and type is doing this stuff. What you can do is then create, my base object, for example, and then if you want to use the metaclass, you can inherit from my base, but define metaclass equal to meta type. Here you can define your own new, go super new, and so on. And we can see what the object is, what the object class is, and what the class of the class is. Right? Shall we run it? Or you want to stare at it a bit? Any question about the code? So far, we're just exploring. So let's run. So meta new, let's call my meta class, right? And then I started printing my prints. So the meta class itself is main my type, the meta class that I define. The future class is my object. This is a string, it's not an object, right? It doesn't make clamps. This is really a string, it's passed as a string. And then I have the basis, which includes my base because I put it in the base of the class definition. And then I have the attributes. So the model is main, the qualified name is my object, and then I have the function new, which, look at that, is assigned from my object new. And then I have some reference for the code and so on. Then it's calling the new. Right now I am in the class new, not in the meta class new. Right, in the class new, I do whatever I do there. The last prints were the object itself, the class of the object, and the class of the class of the object. And these are the object, my type, as I would expect. Right? Questions? All right, shall we move to something useful instead of just printing stuff and see what we can do with metaclasses? And this is where magic starts. So let's say you have an external definition of some objects with types, fields, and data. And you want to expose this JSON, but it could be a database, it could be something from an API. You want to expose this as objects, and you want to use this string as the name of the class, and you want to fill in the data into those objects at runtime. All right, how would you do it in C? You would have to run a precompiler, generate those classes in code, then compile it, and then actually use this generated API. And every time somebody changes on the other side, these objects or the definition, you have to run the precompiler, right? I mean, that's one way. More possibly the other way, you have to do the runtime. But then if you do it at runtime, you cannot use the object as C first level citizen object. You cannot, because this is part of the language. You have to compile it first. But imagine you don't have to.
The compile here, you mean is something like you you include something like you include the head file and you need to combine that first in the online.
Yeah, I mean,
Okay.
if you want to define a new class in C++, you have to compile it.
Yeah,
Here you don't have to. You can define a new class that's called my class, which is defined somewhere else and not defined, not in Python. You can actually have it in Python called my class. Right? And that's what we're doing here. So let's go carefully through this, and then I think we can close it for today. All right, so the first thing is what the method does. The method is basically giving me access to this kind of file. And what I want to do is, I could actually go through the file and define all of them, but I want to be selective and access the classes through a name, like my classes at runtime. So I can pass, what object I want, and then define a new class for that kind of object that are defined in JSON. And this will create a new class, a complete new class for me. So I do this through the get item. Very simple, right? The get item, in the get item, I can check if the key is already in my Metaclasses classes, because I keep a cache. If I define them already, then I just keep them around and I just pass them on. If I don't have it yet, then I need to create the class. And I can do it dynamically. So first thing, I create a new class with type, and I put the name of the class, the key. So my class, my CLS, is going to be the name of the class. I can put self, which is, in this case, is the get item self in my meta is the class, the base. Sorry, not the base, the data entry. So remember, we are at the meta class level. So when I call a function at the meta class level, self is the instance, which is the class. The instance of a meta class is a class, right? So when I apply this to a class and I call get item, self is going to be the class of which is applied. So, and therefore I pass self as the base of my dynamic class, because I want to inherit all the methods that I define in that class. Does it make sense? And then I don't pass any attributes. I don't care for now, just ignore it. But you could actually define there some lambda structures or anything else. I created it. Then what I do is I run through types, and for each key in types was defined up here, right? So I want to dynamically define the fields in this class. They are defined in my JSON file because I know that I have this data in the JSON file. So I want to define the access level to the JSON file. I just go through them. For each field defined, I check what type it is. Here I support only int, right? But you could support all the possible types. And then I just said, okay, set new attribute, the new class which I just created. The name is the field name, and the value is just an integer conversion of x values field. Okay, so x is whatever it's passed to it. The values are the values from above, and then I take from this is dictionary. Then I take the key of the field. What is x here? I am setting an attribute on the new class, and the only argument is x. X is the instance, right? So I'm setting an attribute on the class as a function. This function takes one argument. The argument of every method in the class is the instance itself. So this what it does is checking the self instance dot value. So if I define values within the instance, it will take that particular field from that dictionary. Make sense? So the last thing that I need to do is then when I create this object, I need to assign values with this. And then when I access this field, it's going to read that value because it's accessing my field in this dictionary, and then checking that this is an integer or converting to integer. Right? So I define dynamically an access method for this particular data set. Questions on this before we move on?
Why that X represented the instance?
I am assigning here to a new class a method because this is a lambda function, so it's a method, right? Which is
Oh.
named,
Okay.
right, my field. And well, it basically looks up into the first argument of the function. The first argument is always up,
Got it.
and just look up field into the values, right?
X represent that in new classes, and then new classes attribute to values will get
But it
that.
represents self. It doesn't represent the new class. It represents self within the new class value.
Right.
So far, so good. Okay. So then I just assign it to my cache of classes, and I return it. That's pretty much it. So now, I can define a base where I can initialize, my values. Basically, this is the standard functionality that you want in all your accessory classes. Like if you had more than one definition here, all of them have to inherit my base. All of them get a copy of the JSON, and they can then use it as they want, right? And what I'm doing here is, I init, I check if it doesn't have values, and then I check if, if basically every, one thing. So I support a key in the initialization because I want to initialize an instance, and an instance of this class corresponds to one of these entries in the values, right? Let's say I have here multiple objects. I want to create an instance for each of these objects, and I want to index by the order that they appear in the file. What I can do is I can pass to the init, I can pass the key, and I can just count, and I take the one that is at that particular place in the file. And then I read the values, which is basically the whole dictionary, and I assign it to the self. Here, self equal a deep copy, important, because otherwise I'm going to change the global variable of the dictionary, which I don't want. So I make a deep copy and I put it in self. And then the only thing I do is some cleanup. I delete type, because here I have always this type thing. I delete it so that I don't have it when I access the variables inside the class. Right? That's basically just initializing each object. Now, what I can do is I can create this class and then access it, access the fields like this. O is the first object, and I can access my field. O1 is the second object, and I can access my field. And that will give you the values that you have up here. So now I can do it in an object-oriented way. I don't have to use a dictionary. I don't have to use a dynamic structure. I have, all the things that I would have in a normal object. This was a bit to take it one go. Any questions? Thumbs up. You see what's the next example? Maybe we can catch up with that. No, that's a bit too much. No. So if there's no other question, I would say the next example of metaclasses will be in the next time, so that we can also look at it again and see what they are and how they work. We will see a few other examples which are pretty funny. In particular, I would say, this is quite interesting. Like you can actually define, as you see here, overloading of the same function in Python, which is not supported by the language, but you can actually support it by defining the metaclass. Another thing that you can do, which is really cool, is you can actually support C-style enumerations and actually have them work properly using metaclasses. It's a kind of interesting black magic stuff that you can do. All right, but we'll look at the structure next time. Good. And thanks.
Thank you.